I'm doing this video to cover the use of a test system which I've put together, which is going to be used as a platform to test out a separate application which is used to follow the batch execution process of recipes in real time. So what I'll cover here is a scenario that's going to be used for that purpose. So what I have here is a tank-based system, and it's basically just a mixing tank, and I'm going to follow a recipe both on the HMI as it executes, and I'll also do it then in real time. This is SCL in Siemens S7, so we'll be able to see effectively a state execute down as we go, getting feedback from physical I/O and then some simulated values as well. What we'll be able to watch in real time is just a cabinet here, and basically these relays will come on and off as the recipe executes. The mixing process can be summarized as following. We have a valve here which opens up from a purified water loop. A tank will fill up to 1,000 liters. Then effectively what we have here is a syrup mixture which is going to be added to the tank. Then we'll have a concentrate mixture. Well, some concentrate is going to be added into the mixture, and then effectively we will agitate for a period of time, and then what we will do is we will drain the tank out to a filling buffer tank. So I'll get started here, where I will jump through the sequence, and I'll explain it as we go. So at the very start, this particular valve opens up, and what we'll see here is that the tank level begins to rise. So when this actually hits 1,000 liters, what will happen is that this valve up here will cut off, and then we will see that the syrup mixture will begin to be pumped in, and a control valve will open to a certain percentage as well. So this valve closed, XV09 closed, and then we have this syrup mixture then being pumped, and it's 200 additional liters which will go into the mixing tank. So once we get up to 1,200, what will happen is that the concentrate will then begin to be pumped in. So that will then go up to 1,400. And then essentially, as soon as that happens, then we will agitate just for a period of time. So we agitate, we go up to 40 RPM. Then this guy will come down, and then what we'll see is that these particular valves and the pump, etc., and then we have a simulated value for the flow meter. Now what will happen is that this tank will begin to entirely drain, and then we'll have our process basically ended. The next part now is to run through the PLC code, right? So the PLC code is done in Siemens SCL, and this is effectively structured text. What I'm going to do with this particular application here is manually trigger the sequence to occur, and then what I will do is I will pretend that there are values that are coming back from the physical system. So normally you will be able to have say a tank will have a level transmitter, and the level transmitter will have, say, a scaled signal that comes back, and then it is turned to a meaningful value, such as, say, for example, liters, or something kind of similar. So I'll also then be able to show the actual cabinet which is linked to these relays, as I'd said earlier, and they will trigger on in real time as the program executes. Okay, so first off, I'm live in the program, and I can see that the state is at 0, and it has to go at 1 into 2 into 3 into 4 as the actual program moves along. So I'm going to turn the value to a 1, and we'll see what occurs here as the program executes live in the PLC. So I will write down, and what we'll see here is that the representation of the valve has come on, and that particular guy was up here. Okay, so essentially then what we're waiting for is the tank to fill up to 1,000 liters. So I will go here and I can see that the address is DB3 DBD42. So here I'll go DB3 DBD42. It's a real number, and I'm going to put the tank level as being 1001. Okay, so I'll write that down, and I can see then that my valve has turned off. Okay, so that's the input valve from the purified water, and basically what I'm doing is I'm pumping up the syrup right now. Okay, so then I'm going to put down, we were looking for the tank level to get up above 1200, so I'll write that value down, and then what we'll see here is that we are now pumping the concentrate. So the values will refresh up here when needed. Okay, so what we're looking to do is get up to 1,400. Okay, so we'll get up to 1,400, and after this then what's going to happen is that we're going to agitate for a timed period. So I'll write that down and we'll jump across here. And basically what's happening here is that we're in a timed situation. So the agitator's come on, it's gone from 0 and it's going to stay at 40 for a given period of time. And essentially after this timer has gone up, what we'll do is we'll have these 3 valves here, and they represent the drain valve and then the other valves that we're directing out to the process, to the filling tank. Okay, so our mixing tank is draining away, but it will only fully drain once, because this is kind of where we are. We're down at this particular area here. It's only going to drain once the tank goes back to 0. So we'll see how much is in the tank, and it's 1,400. So when we bring this guy back to 0, what's going to happen is that our 3 relays are going to go off in real time. So we'll send that down, and they all switched off in as the tank had nothing any longer in it. And basically what we end up with is a tank that effectively just has it's ready to be cleaned, and then effectively we have a CIP system then which can come in and basically run a cleaning cycle through it. Okay, so the purpose, as I said, of this presentation was just to outline a testing scenario which will come for a separate application further along. Thank you.